So let us look at one of the problem, that is rotating the image. That means you need to rotate 90-degree clockwise. So simple. Now let me show you how it actually works. So let me take this here, then take this here. So this is what my question is. Now I need to rotate. It means you need to like simply rotate. You imagine like this. You are rotating 90-degree. That's it. 90-degree means what? One time you are rotating. So box will be like this. So this is your box. So imagine this is something like key. So if you rotate, you should get like this, right? So this is what the rotation is. That is what they have done. So let us look at how we can solve this one. So there is a technique here. First thing you do transpose. Then second thing what you can do is swap the columns. So these are the two things that I am going to do. Let us do the transpose. Let me write the code for that and you will understand. It is so much easy, right? So obviously I should take int m is equal to matrix dot size, then int n is equal to matrix 0 dot size, then for int I is equal to 0, you go till the last row, then I plus plus, then column. For column for int j will start from 0 but it will go till I, then j plus plus. So if you have any doubt on this transpose, you can simply iterate it. So take one example, take this example only, and you need to transpose. That means transpose means what? If you don't know what is the transpose, let me explain you what is the transpose. Transpose means 1 2 3 4 you have. So column has to be changed into row. Like 1 2 you print in column wise, right? Row wise you should be printed like a column wise. So that is what you need to do. So for this, the code is this. You can look and you take an example and iterate. That would be the best practice that you can do. So swap. You need to swap matrix I and j with matrix j and I, right? You need to swap like this. So let me explain you how it actually works. You go through the row, then you transpose this, then you transpose this. Means you are swapping 4 and 2, 7 and 3. So that will work. So let me explain you here. So if you transpose this matrix, you will get 1. You swap this 4 and 2. So 2, 4. So you swap this and this. You don't need to take care about this diagonals. It will remain same. Again, 3 will come here, 7 will go there. Don't take care about the diagonal. Again swap 8 and 6 and 8. That's it. This is what the transpose is. So you are writing this row in column wise, this row like this, and so this row like this. Now I have written for row. So what I need to do is so let me take that example. So I have written the transpose, right? So let me swap this column. So let me swap this column. So what I have here, I have 9. So if I swap, means you take this column and this column, swap them, right? 7, 8, 9, 4, 5, 6, 1, 2, 3. So that's it. That is what the result you get. So when I say swap, you don't think that only first and last column should be swapped. You should swap like this. If imagine there are 5 row columns, you swap this and this, then this and this, then you swap this also, then what will happen? It will remain same. That's it. We can do like that. So let me write a code for swapping. So this is for transpose. So this is for swap the column. columns. So for int I is equal to 0, I less than, so what would be the row condition? Row condition is simple, row will not change itself. So you are swapping the same row elements, so don't take care about the rows. For columns, so let me go till, so I don't need to go till last. Why? Because if you go till last, then again and again you will be swapping. So you will be swapping this, then again if you your imagine your column index will go here, then it will swap with itself. Okay, that is also not problem for me. So time would be taken more, but that would be not a problem. So imagine the control will move till here, then it will swap again this and this, again you will get the same matrix. So you need to take care about this condition. You need to take care, you need to go from 0 to I. J should be what? Less than n by 2. N is 3, then n by 2 is 1.5, that means 1. So you are going till 0, that means you are traversing only, swapping only first column, that's it. So you are not even touching this middle column, so time would be saved. Now J++, you need to swap, what you need to swap is matrix. I will remain same. J you need to swap with what? So that would be like, so what you will swap with J? So what is the column? So indexing 1 2 3 0 1 2, right? So 0 should be swapped with 2, that means what? So number of row columns is what? 3. So 3 minus 1 is what? 2, right? 2. So you swap this 0th column with n minus 1 minus I, right? I is 0, right? You can get, right? So I means 0 here. So imagine there are 5 columns, so indexes are 0 1 2 3 4. You need to swap this and this. So I is what? So imagine the J, right? J, I am talking about J. I is for row. J is what? J is 1. When J will be 1, you need to swap with n minus 1 minus J. Means what? N is what? There are 5 columns, so 5 minus 1 is what? 4 minus 1. You will get what? 3. Means swap with this 3 column, right? So I need to swap with n minus 1 minus J. So that's it. I need to return. I don't need to return because reference I have given. So let me run. Let's see whether I will get any syntax error. So I got. Definitely I will get. So let me run. So again I am getting some syntax error. Let us see why we are getting this. So J is not declared. That is what the syntax error. So let me run again. So all the results are accepted. Let me submit. Now I got the result, right? So this is about this problem. So thank you.